I'm Karthikeya, and on behalf of my co-authors from CWI in Amsterdam, Delft University of Technology from the Netherlands, and Nara Institute of Science and Technology in Japan, I will present our paper for CHI 2024 titled Share Your Reality, Investigating Haptic Feedback and Agency in Virtual Avatar Co-embodiment. Virtual reality, or VR technologies, enable people to immerse themselves in artificial digital worlds. This has enabled previously impossible interactions that challenge our assumptions about virtual bodies and online social coordination processes. In VR platforms, we use avatars, which are virtual bodies that we use to interact and navigate through the virtual environment. Typically, these interactions adopt a first-person perspective. This is done to create a sense of embodiment towards the virtual avatar. Sense of embodiment can manifest in three dimensions. Sense of body ownership, which is the feeling of having a virtual body. Sense of agency, which is the feeling of control over the virtual body. And sense of self-location, which refers to the feeling of being inside a virtual body. In our research, we explore the concept of virtual co-embodiment, which is a multi-user experience where two users embody a single avatar and share control over the avatar's movements. We can achieve this through the weighted average co-embodiment method, which involves assigning a weight between 0 and 100% to each user and generating the movement of the shared avatar by interpolating the weighted average of the real-time position and orientation of the controllers of both the users. Experiments of virtual co-embodiment have shown that participants report high levels of perceived control with low levels of actual control over the shared avatar. This enhanced perception of control can be useful for rehabilitation specialists and support personnel that use immersive technology for the treatment of physical and cognitive function of individuals that have suffered from stroke or dementia respectively. This concept also provides methodology for assistive accessibility for users who might struggle with the setup and navigation of virtual environments. In such a multi-user experience, another dimension called social presence comes into play. This refers to a person's perceived ability to access another individual's intentions, intelligence, and sensory impressions within a virtual environment. Without a high sense of social presence, collaborative tasks become difficult. Virtual co-embodiment leads to a situation where there's intermingling between self-presence and social presence, where the identity of the self is intrinsically linked to the avatar and also to the presence of another intentional subject. And this intentionality is translated through the amount of control available for each person over the shared avatar. Researchers have explored virtual co-embodiment in relation to users' perception of their embodiment of the shared avatar and its use for motor skill learning. And extensions of this concept have highlighted the need for non-verbal communication mechanisms to be integrated into this concept in order to enhance the sense of embodiment towards the shared avatar. This is because a specific challenge in co-embodiment is that visual feedback alone of the combined motion of the shared avatar does not fully provide the intentional information of one's partner. In our work, we integrate haptic feedback as a position-aware feedback mechanism to positively influence the experience of social presence. To do this, we draw on the perceptual crossing paradigm, which was conceived to study social interaction dynamics in online environments. Here, perceptual crossing refers to situations where two perceptual activities of the same kind meet each other, such as when two people catch each other's eyes or mutual social touch. Building on the idea of haptic perceptual crossing, we implemented haptic feedback when users' hand positions overlap in virtual space during co-embodiment, and investigated how these haptic cues can enable awareness of each other and coordination within co-embodied users. Our main research question was, how do haptic feedback mechanisms and varied avatar control distribution influence users' sense of agency, co-presence, body ownership, and motion synchrony in targeted and free choice virtual avatar co-embodiment tasks? We conducted a controlled within-subject study with 20 participant pairs. where each pair of participants performed 2 cube selection tasks, targeted and free choice. In the targeted task, participants used the shared right hand of the avatar to touch a cube that spawned in their field of view. Once the shared hand collided with the cube disappears, and after a second delay, another respawns at a pseudo-randomized position. This repeats for a total of 17 times in each track. In the free choice task, 5 cubes would spawn in front of the participant's field of view. The participants then had to move the shared right hand to touch one of them to progress. In this case, when the shared hand collided with any of the cube, all the cubes would disappear, and after a second delay, all the cubes would respawn back in the same position. We implemented these 2 types of tasks in order to better understand the influence of movement freedom and intention on the level of embodiment. We examined the effects of positional haptic feedback and avatar control distribution on participants' sense of agency, co-presence, body ownership, and motion synchrony for both the tasks. Our findings showed that users had a lower sense of agency in conditions with haptic feedback compared to conditions of no haptic feedback. They also experienced higher agency during the targeted task compared to the free choice task, and their experience of co-presence and body ownership were significantly higher in tasks where there were multiple targets, or the free choice task. We also found that users' hand motions were more synchronized during the targeted task. Our exploratory work offers 2 primary contributions. We integrate the concept of perceptual crossing into the paradigm of virtual co-embodiment to enable position-aware haptic non-verbal communication cues between 2 users. We also provide empirically backed insights showing the influence of haptics on the perceived sense of agency during targeted and free choice selection tasks under variable control and shared virtual hands. In our paper, we provide cautionary considerations for the role of vibrotactile haptic feedback and shared control distribution in this emerging area of virtual avatar co-embodiment.